Okay, let's take a look at equal fractions. So let's take a look at an example. We are always going to start off with over equals over. Just a fraction equals another fraction. It's a great setup. We're going to use that all over the place. So let's take the first question and let's do 1 over 2 equals what? Over 4. Now keep in mind, I could use a question mark or I could use an X, for example, but I'm just not going to put anything. And I'm going to take a look at the bottom. Now, how do I get from 2 to 4? Now keep in mind, when I ask how do you get from something to another thing, I mean adding, subtracting, multiplication, or division. And in this specific case, we want to use multiplication. So how do I get from 2 to 4 using multiplication? And I know that 2 times 2 is 4. And if I couldn't figure that out, I could have taken the 4 and divided it by 2 on the calculator to figure out that we're multiplying by 2. And if we do that to the bottom, we must also do that to the top. And on the top, 1 times 2 is simply 2. I can check this on the calculator. So if I take 1 divided by 2 and I do the same 2 divided by 4, they are both equal to 0.5. So we can say that equals 0.5. I can circle my answer and say check mark. The left-hand side must equal the right-hand side. It will allow you to use your calculator to figure out if you did a step correctly. Okay, so let's take another look at another simple example. Let's start off with over equals over again. So let's take a look at 1 over 3 equals what over 6. And again, how do I get from 3 to 6? I simply times by 2. And if I multiply the bottom by 2, I need to, again, multiply the top by 2. 1 times 2 is 2, and we get 2 divided by 6. We can check that on the calculator. And if we press 1 divided by 3 and also 2 divided by 6, we're going to get the same decimal, 0.3 repeater expressed with a hat on the top. And if the left-hand side equals the right-hand side, then we know we've done it correct. We can circle our answer and say check mark. Now, keep in mind, this setup over equals over. We can set it up with ratios as well. A very similar setup. Number, colon, number. Again, number, colon, number. Just like over equals over. Looks a little bit different, but we're going to be using the same rules. Whatever you do to the bottom, you must do to the top. And now we're going to take a look at some more examples with equal fractions and eventually ratios as well. Whatever you do to the left, you must also do to the right. Make sense? Okay, so now we're going to take a look at another example, the same example that we did in the top left, the first example, but we're going to look at it a different way. So let's take 1 over 2 equals what over 4. Could have started with over equals over, I just started writing. Okay, so what if I looked at this differently? What if I visualized, oh, well, I want to go from 4 to 2? Well, does it matter? We'll find out. So how do we get from 4 to 2? Well, we could do it on the calculator, but we need to simply divide by 2. Now, we want to figure out what's on the top of 4. So we're going to go in the opposite direction. Now, order absolutely matters. So if we go in one direction, we must do the opposite operation in the other direction. So if we're going to the left, dividing by 2, on the top we must multiply by 2 times 2, and we're going to get the same answer as we did before. Now, what if we took a look at the exact same question again? Let's start off with over equals over this time, all the same. And let's say 1 over 2, but this time let's leave the bottom out. Let's put the 2 on the top. Now we know what the answer is. We just want to show you all the different ways. So in the last example, we learned order matters. Now in this example, I'm just going to look at this differently and recognize that on the left-hand side, if I want to get from 1 to 2, I simply multiply by 2. And whatever I do to the left, I must absolutely do to the right. So if I multiplied the left going down by 2, I must also multiply the right going down by 2. And 2 times 2 is 4. And we can circle our answer. And again, we get the same answer as we did before, the same setup. We're just learning all sorts of different ways. Keep in mind, there are so many different ways to do this kind of stuff. Let's take a look at 1 over 2 equals x over 4. Well, some people like to do what's called get a lowest common denominator. Let me write that down, LCD. So what is the LCD? Well, I'm going to start off again with over equals over to really show that this is what we're doing here, over equals over. Now I need to get a lowest common denominator. What's the lowest number 2 and 4 both go into? Well, let's count by twos. 2, 4, oh gosh, they both go into 4. So we can put a 4 on the bottom of both setups. Now, how did I get the 2 on the left bottom to be 4? Well, I simply multiplied it by 2. And if I multiply the bottom by 2, I must also multiply the top by 2. And on the top left, 2 times 1 is simply 2. And now that we have the same denominator, I can put x on the top, and I can clearly see that x is equal to, that x is equal to 2, the same top. If I get a lowest common denominator, the same bottom, well then obviously the tops must equal each other. So a recap, top left, due to the bottom, due to the top. Same example, due to the bottom, due to the top. And we're going to work with ratios as well. Direction, the next example in the next line, direction matters. If we go in one direction, we do one thing, and we want to go in the other direction, we must do the opposite operation. Now we can work on the bottoms and the tops, but we can also work on the left and the right. And then again, we can also do the lowest common denominator model. A little bit later in equations, we're going to take a look at the last example and see how we can simply multiply both sides by things to solve the equation, but we'll look at that in equations a little later. Okay, so let's take a look at another example. 5 over 20 equals 1 over x. Why not put in an x this time? So I want to decide how I get from one direction to another. Now, lots of times you're going to see different things than I do. Who cares? Just go for it. So if I take a look at how do I get from 5 to 1? Well, if I want to go to that direction, I just divide by 5. Keep in mind, you could have gone in the other direction and gone from 1 to 5 and said times 5. Who cares? It doesn't matter as long as you follow the rules. Do to the top, do to the bottom, do to the left, do to the right. And direction matters. So if I want to go in that same direction, then I simply do that same operation. And 20 divided by 5, x equals 4. Keep in mind, you could rewrite what x equals off to the right, or just simply do a little trick method like that. So again, we briefly touched upon ratios. Why don't we take a look at ratios again now? So let's take a look at a ratio. 1 to 2 is 2 to what? So if I'm on the left-hand side and I get from 1 to 2, I can say times 2. And I must do that same operation times 2, and 2 times 2 is 4, and I can circle my answer. Obviously, I could have taken a look at the tops. 1 times 2 is 2, and 2 times 2 is 4. As long as you stick to the basic rules at the top of the sheet. Due to the left, due to the right, due to the top, due to the bottom, and direction absolutely matters. So let's take a look at 3 over 5 equals x over 12. Now, this one's a little more difficult because I don't know how I get from 3 to 5 or how I get from 5 to 12 with simple answers. But what I want to do is I just want to divide. If you don't know, just divide. Usually bigger divided by smaller. So let's take a look at 12 divided by 5. Now shown off to the right, I can say 12 divided by 5 equals 2.4. Keep in mind, I do my side work way off to the right. This is work that I'm eventually never going to do, and I don't want it to be anywhere near the work that I'm doing to get in the way, because I'm going to work all over the place near this work. So I just figured out that my multiple is 2.4. And obviously, if I want to go from smaller to bigger, I must times by 2.4. And if I did that to the bottom, I must also do that same operation to the top. And 3 times 2.4, I'm just going to do that on the calculator. Keep in mind we could do long multiplication, but we're going to get 7.2. So 3 times 2.4 is equal to 7.2. So x is equal to 7.2. And I'm going to circle my answer. Again, you could have rewritten it like I did in the notes, etc. And then I'm just going to make sure, I'm going to check my answer on the calculator. So I'm going to test the left-hand side. 3 divided by 5 is 0.6. And the right-hand side, 7.2 divided by 12 is also 0.6. So check mark. Everything should work after. It's just a great tool to check your answer on the calculator. So keep in mind in the notes, if you weren't allowed a calculator, if you want to do 12 divided by 5, you're going to have to do long division in long form. So make sure you know how to do that if you're not allowed a calculator, etc. It's always a great tool. So now let's do another exactly the same example, but looking at it a little bit differently. So let's take 3 over 5 is equal to x over 12 again, the exact same example that we just worked on. But what if I looked at it differently and I wanted to go from 3 to 5? Well, how do I get from 3 to 5? Well, I'm usually going to do bigger divided by smaller. It just makes better sense in my head. So if I take the calculator out and I do 5 divided by 3, bigger divided by smaller, I get a factor of 1.6 repeater. So off to the right, I'm just going to write that down. 5 divided by 3 equals 1.6 repeater. The reason why I do that division is so I can figure, the reason why I do bigger divided by smaller is it's going to be easier for me to figure it out. So when I'm looking at it again and go, how do I get from 3 to 5? Well, I must multiply to get to the bigger number. So I can say times 1.6 repeater. And then whatever I did to the left, I have to do to the right. But keep in mind, we're doing it in the opposite operation. So if we do the left-hand side, on the left-hand side, if we multiply and we do the opposite direction on the right-hand side, that means we have to divide. So I'm going to divide by 1.6 repeater, again represented by a hat on the top. And then I'm going to take my calculator out and I'm going to do 12 divided by 1.6. 6666666. The only way we can do repeater on the calculator, we're just going to get an approximate answer, and we get 7.02000000. So we can say equals 7.2, and we can circle our answer. Again, you could have rewritten it and said x equals somewhere else cleaner on the page, but notice sometimes I rewrite it and sometimes I just do a lazy little version. Now again, I can check my answer like I did before. 3 divided by 5 is 0.6, and 7.2 divided by 12 is also 0.6. So I know that the left-hand side is equal to the right-hand side. And if the left-hand side equals the right-hand side, then we can say check mark. It's a great way if you're at home and you can't figure out if you did it correctly, well, you can just check on your calculator and find out if it's correct or not. If it's not, then you can figure out that you've done something wrong, teaching you how to do it on your own at home. Great, so that is an introduction to equivalent fractions or proportions. We're going to be using this all over. We use this in real life, called the transitive property. If something is to something else, well, something else is to that other thing. Let's take a look at a quick example of that. If A equals B and B equals C, you may not be able to see that. I'm going to move that up a tiny little bit due to my camera position. If A equals B and B equals C, what do we know about A and C? Well, A simply equals C. Again, called the transitive property. We're going to be using that all over the place in math and in real life. So again, that's equal fractions. We're going to be using that for the next few pages of homework, and we're eventually going to look at how we can relate this to a real life example like shapes.